Unacademy. Let's crack it.
Hello viewers, so I welcome you all to this Battle of Brains conducted by Unacademy. So Battle of Brains is a knowledge fight which happens between two toppers from the same branch. So I'm Shalini and I got a rank of 18 in GATE 2021 from ESE. So currently I'm in my fourth year from Osmania University, Hyderabad. So today we have another topper with us, Manoj Kumar. So Manoj Kumar, please introduce yourself.
हेलो एवरीवन, मेरा नाम मनोज कुमार है और मैंने अपनी बीटेक जो है 2017 में ट्रिपल आईटी इलाहाबाद से पास आउट की है और मैंने इस साल गेट 2021 में इलेक्ट्रॉनिक्स एंड कम्युनिकेशन में ऑल इंडिया रैंक 3 सिक्योर की है। और आज हम यहाँ पर हैं, मैं और शालिनी, दिस वॉर ऑफ ब्रेन्स, जिसको हम नॉलेज फाइट भी कहते हैं टॉपर्स के बीच में। यहाँ पे हम एक दूसरे से 10 क्वेश्चंस पूछेंगे और एक दूसरे की नॉलेज को चेक करेंगे, ठीक है? या शालिनी, सो हम में से किसको स्टार्ट करना चाहिए?
Okay, I'll start.
Okay, ladies first. चलिए. Yes.
Okay, so my first question to you is from control systems.
Okay.
So in the second order system, standard second order system, when you get an oscillatory response, or for what value of zeta you get an oscillatory response?
Okay, so in the standard second order system, the first to the condition so that the system does not have this oscillated response is zeta greater than or equal to 1. So to have this oscillated response, zeta should be less than 1 and greater than or equal to 0. Yes.
So that's the right answer. So you'll get 10 points. Okay. So now I think it's your turn to ask the question. First question.
और स्टूडेंट्स, एक बात मैं आपसे बता दूं कि कंट्रोल सिस्टम सब्जेक्ट में अगर किसी को प्रॉब्लम है, सो आई एम टीचिंग द कंट्रोल सिस्टम ऑन अनअकैडमी, सो आप लोग मुझे फॉलो कर सकते हैं वहां पर, एंड दैट्स व्हाई आई एम एबल टू आंसर द क्वेश्चन ऑन कंट्रोल सिस्टम सो इजीली। और आप लोग मुझे फॉलो कर सकते हैं अगर आपको कोई प्रॉब्लम फेस होती है कंट्रोल सिस्टम में, ठीक है? हाँ शालिनी, आपसे फर्स्ट क्वेश्चन है मेरा, दिस इज फ्रॉम सिग्नल एंड सिस्टम। व्हाट इज द कंडीशन फॉर द सिस्टम टू बी डिस्टॉर्शनलेस?
So, as you know, for the distortionless system, the output should be like proportional to the input itself. Like it can be some constant times multiplied by the input. So, in that case, my magnitude response for the system, it should be a constant. Okay, and the phase response, which is there, it should be proportional, linearly varying with frequency. So, in that case, my phase for the system will be some k times of omega. Okay, so in that case, we call it a distortionless system.
Yes, absolutely right. Or you get the full marks for that question. Yes.
So my next question for you is from EMPL.
Yes.
Okay. So as we know about the transients for the transmission line, so as soon as we switch on, like at t equal to 0 plus, and in the steady state at t equal to infinity, what is the impedance?
Transients on a transmission line. At t is equal to 0 plus, when we close this switch, okay, so what we consider is since we have just on the switch, so there we assume there is no reflection. As there is no reflection, we consider the load is matched. So at t is equal to 0 plus, we consider the load is the load seen as the input is Z0, which is a characteristic impedance. And at t is equal to infinity, there is a steady state, and as steady state, the load seen at the input is this actual load ZL.
Absolutely correct. So you'll get 2 points, 10 points, and 10 points. Okay. So the next question is from your side.
Yes. The second question. This is from EDC. Um, the question is, for the N-type material, in which direction the Fermi level moves with increasing temperature?
So, we have learned that as we increase, like for the N type or the P type, as we are increasing the temperature, we know that slowly the concentration of the electrons and holes, it keeps on increasing, and at a particular temperature, it loses all its intrinsic properties, and slowly we have the generation of the thermal generation of the minority carriers. So in that case, I can relate this to the Fermi level. My Fermi level slowly starts moving towards the center of the forbidden band, and it meets the intrinsic level after some point. So that
Yes, absolutely correct. And you get the full marks. Now over to you, Shalini.
Yeah. So my next question is from analog electronics. So the Schmidt-Trigger circuit, right? So
Yes.
in that, if we are operating it in the non-inverting mode, can you tell me about the UTP and the LTP points, the upper threshold point and lower threshold point?
So this Schmidt trigger circuit. So this Schmidt trigger circuit, it is a bistable circuit. So meaning of bistable is the voltage, the output of the circuit can stay in two levels. It is positive saturation plus Vsat and the minus Vsat, which is negative saturation. So when we change the input, the output will switch between these two levels. So the upper threshold point is a point for the increasing input when the output switches between the plus Vsat and minus Vsat. Similarly, for the decreasing input, when the output switches from minus Vsat to plus Vsat, this point is called the lower threshold point, LTP.
Right. You will get 10 points now. So the next question is from your side.
So next question, this question is from the distal electronics. This is one of the basic question, but most of the students get confused. What is the basic difference between the latch and the flip-flop in terms of triggering?
Okay. That's a trigger. So basically, we have two types of triggering. One is the level triggering and the other one is the edge triggering. So in a latch, we have the level triggering, wherein as long as the pulse is high, you can reflect a change in the states of the latch. But for a flip flop, we have edge triggering. So it can be either negative edge triggered flip flop or a positive edge triggered flip flop. For a negative edge triggered flip flop, as we know, when it goes from when there's a transition from 1 to 0, then the flip flop can change states. And for a positive edge triggered flip flop, then it goes from 0 to 1. When the clock transitions from 0 to 1, then we can see a change in state of the flip flop.
Right, absolutely. So you get the full marks for that.
The next question will be from my side. So I'm asking you a question from EDC. So we know the very popular relation, the Einstein relation in EDC, right?
Yes.
So can you tell me which two quantities does this Einstein relation relate to?
Yes. So this Einstein relation, we use this relation more frequently in this EDC subject. So this relation says कि for any type of, like for silicon or it is germanium, whether it is N type or P type, the ratio of a diffusion constant and this mobility is always constant and it is equal to Vt. Here the Vt gives you this volt equivalent of temperature. Okay. Yes.
That's actually correct. So you get 10 points. So the next question is from your side.
So the next question, this is from optical fiber. This is one of the topic which most of the students neglect, and this year the question has been asked, and I guess 99% of the student answered this question wrong. So here is the question for you, Shalini, from optical fiber. What is the acceptance angle?
I think I'm going to lose on this because, as you said, most of the students neglect this. Even I didn't study this properly. I just went to the basics. So, but as far as I remember, the acceptance angle, it is something it can give the like measure of how much light actually the optical fiber can take, like how much the light it can gather.
Yes.
Is that right?
Yes, yes, correct. It's correct. It actually represent means at how much this angle range. If you incident the light in a fiber, it will collect that light and the light will be propagated. So your answer is completely correct, and you get the full marks for that. Now over to you.
Okay. So my next question to you is from EMTL. Okay. So tell me which is the dominant mode in a circular waveguide?
In a circular waveguide. So this is the topic which is introduced in GATE 2021 by the IIT Bombay.
But we didn't get any questions.
Yes. So, but student for the 2022 and 2023 GATE, they should prepare this topic because we can expect the question in a coming time. Okay. So this dominant mode in case of this circular waveguide is TE11. Yes, TE11.
Okay, that's correct. So now it's your turn.
So my fifth question for you, this is from UMTL. So tell me the condition on load, like what will be the type of a load when we want the reflection coefficient magnitude equal to 1.
Okay. Since you're telling the magnitude is equal to 1.
1.
So basically we can have a purely inductive load or a purely capacitive load. And also in the case of short circuit and the open circuit also, this reflection coefficient will be equal to 1. Because as we know, the formula is ZL minus Z0 by ZL plus Z. So because you're talking about magnitude, I can include short circuit also.
Yes, correct. Absolutely correct. We will get the full marks. So now over to you.
Okay. So my next question to you is also from PMT. So as we know that there is an evanescent mode in the waveguides. So can you tell me what does that evanescent mode actually mean?
So yes.
Or what is the condition for that?
So basically, evanescent modes are the non-propagating modes in a waveguide. Okay, non-propagating mode. So it occurs when the frequency we are using in a waveguide, it is less than the cutoff frequency. And we know if we apply the frequency, operating frequency less than the cutoff frequency, this that particular frequency will not propagate inside the waveguide. So what exactly happens? This gamma, which is our propagation constant, when this cutoff frequency less than the cutoff, when this applied frequency is less than the cutoff frequency, this gamma becomes completely real. And the real part of gamma is called the attenuation constant. Or so in that case, the wave is totally attenuated and there is no propagation. Yes.
That's perfect. Okay. So you get 10 points for this question. So the next question is from your side.
Yes. The next question is question number 6, and this is question from the analog electronics from the oscillators. This is one of the important topic which students study. So the question is, what is the Park-Hussein criteria for feedback oscillator?
Okay. So the Park-Hussein criteria, it basically has two conditions. The first condition is the A into beta, that is the open loop gain and the feedback factor beta. The product should be greater than or equal to 1. As well as the second condition is the total phase around the loop. It should be either 0 degrees or 360 degrees. So these two conditions are to be satisfied for it to work as an oscillator. Okay.
Correct.
So is that right?
Yes, yes, absolutely. You get the full marks. And now next question from you. Over to you.
So my next question is from communications. Okay. So we know about the slope overload distortion and the granular distortion, right? So
Yes.
can you tell me the conditions for these two? Like when does it happen?
Yes. So both of these type of distortion, both of these occur in what we call is delta modulation. Basically, what happen is in case of a slope overload distortion, when we construct our this signal in delta modulation, then the slope of constructed signal is less than our massive signal. Basically, massive signal is changing very fast, so it has a very high slope. and the reconstructed signal slope is less. So in that case, the slope overload distortion occur, and the condition is delta by Ts, which is the slope of a reconstructed massive signal. It is less than the slope of masses, which is d by dt of mt. In the same way, the granular distortion occurs when the slope of a massive signal, applied massive signal, is changing very slowly. Okay. So in that case, this slope of this reconstructed massive signal delta by Ts is greater than d by dt of this mt massive signal. So these are two noises which are present in delta modulation, which are basically we don't want. So that's why we go for this adaptive delta modulation. You will study in a communication.
So that's a very good answer. So you'll get 10 points for this. Okay, so the next question is from your side.
So next question is also from the seventh question from analog, and this circuit is most frequently used in BJT. ठीक है, और ये क्वेश्चन भी बहुत पूछा जाता है. Let's see which biasing circuit gives the best stability in BJT.
As far as I remember, the biasing circuit that we have were fixed bias circuit. That is the first thing that we learn, and then we learn about the connector to base bias circuit.
Yes.
The self bias circuit. Okay, so among these three, the self bias circuit is the the best one for the biasing. As we know, because in the fixed bias circuit, stability factor is really high, like it's around some beta 1 plus beta. So so that is the reason the fixed and for the self bias circuit is the best one. It's even compared to the connected to base bias circuit, it has a very good value. So that is the reason fixed self bias circuit is the best.
Yes, it's best. It is correct, and you get the full marks. Now over to you, Shalini.
Okay, so my next question is also from PMDF. Okay, so is a lossless line a distortionless line, or is a distortionless line a lossless line? So students get confused with this. So
yes.
Can you tell the answer?
So yes, I know the answer. Let me first tell you, so that the student who are watching, उन्हें पता चले कि what is distortion line, what is lossless line, then we can compare both of these. So first, students. So lossless line. So lossless line is a line where when there is no loss, whatever the signal we are transmitting, there is no loss in that. So the loss component in this transmission line are the resistance as well as the conductivity between the two lines, because in that case the leakage current will be there. So conductivity is also the loss component. So both of these should be low, or we can say they should be zero. So the condition for lossless line is R is equal to 0 and G is equal to 0. But for the distortionless line, basically distortion line is a line when we apply the signal at the input, the signal should not change its shape. The shape should remain same. Okay, magnitude can reduce, but shape will remain same. So the condition for that is the time constant L by R and the G by C by G both should be equal to same. So if R and G equal to 0, this condition for distortionless will be satisfied every time. So we can say this lossless line will be distortion always, but vice versa is not true.
So that's the correct answer. So you get full marks, 10 points.
Thank you.
Now
Yes.
it's your turn to be asked question.
Yes. So my next question, the question number 8. The question is, what is the limitation of this Mason-Gain formula to calculate the transfer function?
Okay, so as we know, the Mason-Gain formula is actually used to find the transfer function, by using the number of incoming branches to the output node and the outgoing branches so actually the output node, we consider it something which has got only the incoming branches, and the input node is something which has got only the outgoing branches. So suppose if we have an SFG wherein we don't have an input node which is with only the outgoing branches, in that case we create a dummy node and then we solve it. So that is a limitation of the Mason-Gain formula, where you cannot apply it when there is no input node with only the incoming outgoing branches.
Absolutely. Now over to you for the next question.
Okay, So my next question is from communications. Okay. So we know that there is a square law modulator, right? In analog communication, we have learned about it. So can you tell me what is the condition for the carrier frequency to generate the AM wave from the square law modulator?
So this square law modulator, this is used to generate the AM signal. Okay. So when in this square law modulator, the input is this our massive signal and the carrier signal. So the components which we use is there is a summer which add both of these signal, and there is a square law modulator which will generate the square cube terms. Okay, this is the characteristic of this square law modulator, and then we use this band pass filter so that we can obtain our this AM signal. Okay, so the condition which we should keep in mind, because we are using this band pass filter, so the cutoff frequency, the frequency for the carrier should be less than 3 times the maximum message frequency. Otherwise, there will be overlapping in a band, and we cannot, we can, हम लोग अपने जो बैंड पास सिग्नल जो कि हमारा AM सिग्नल है उसको obtain नहीं कर पाएंगे, filtering use नहीं कर पाएंगे. So we cannot be able to use the filtering. So we have to maintain that condition. Carrier frequency should be equal to 3 times the maximum message frequency. Yes.
Correct answer. So you get 10 points. So
Yes.
next question is from your side.
Next question. This is the question number 9. So the question is, which controller is used to increase the speed of a response? Mainly, we are talking about the transient part, transient response.
Basically, we have learned about different types of controller, like a proportional controller, integral controller, derivative controller, PID controller, PI and PD controller. So among these controllers, the PD controller is supposed to increase the speed of the response. So our PI controller, it actually lags in response. It makes the system sluggish, but the PD controller is supposed to increase the speed of response.
Yes, correct, absolutely right. So you get the full marks, and now the over to you for the next question.
Yeah. So far I think it's a tie. So this is my last question for you. So let's see, like after this, who's gonna win? Okay. So my question to you is, if we learned about the booster angle in EMTL, right? So
Yes.
suppose my wave is incident at booster angle, then what will be the polarization of the reflected wave?
Actually, there are 2 types of polarization. One is parallel and other one is perpendicular. So I'm not able to recall the polarization for which we apply the Brewster angle, but I remember the definition of this Brewster angle. So I'll gonna tell this. So the Brewster angle is the angle of incidence at which, if we incident our wave at the boundary of the 2 media, the reflected wave is 0 and the incident wave is completely transmitted. So this is a definition, but I don't remember what will be the polarization of this reflected wave, because I don't remember actually the type of polarization for which we apply this Brewster angle concept, which is applicable.
So I'll tell the answer.
Yes.
So as you said, because there is complete transmission, so this booster angle concept is applicable in a parallel polarization. So which means for parallel polarized part, there will be complete transmission. So in the reflected wave, we don't have the parallel component. So obviously, it will be equal to the linear polarization. The reflected wave will have linear polarization. Okay. So I think you will lose marks on this because you didn't answer to the point. You just told about the definition. Okay. So let's see in the last question. If I answer it correctly, then okay. So it's your turn now.
Okay. So this last question, this is from EDC. So most of the time we talk about this mobility of electron is greater than the mobility of holes, and we frequently use it. Sometimes we tell in transistor, okay, which type of transistor we should use, NPN or PNP, and we tell, okay, use the NPN because electron has a higher mobility, blah blah. Most of the time we use it. So tell me why is mu n is greater than this mu p? Yes.
So we know that the formula, basic formula for mobility is Q by M star into tau. So we can observe from this relation itself that the mobility is inversely proportional to the effective mass of the electrons and holes. So because the effective mass of the holes is greater than the effective mass of the electrons, we have the mobility of holes is less than mobility of electrons. So we know that the effective mass is not the normal mass that we consider. It actually takes into all the forces that are acting on a particle. Okay. So because the the binding force from the nucleus is more for the holes and than the electrons, they have got an effective mass that is greater than electrons. So because of that, we have the mobility of the holes greater than less than the mobility for electrons. Okay. So is that right?
Yes, it is absolutely right. And so finally, you got all the questions correct and get the full marks for all. And so finally, we have the winner, Shalini Reddy, for this knowledge fight. Congratulations, Shalini.
So actually, I would like to mention a point here. So I'm teaching electronic devices and circuits on the Unacademy platform. So if you have any doubts regarding EDC, then you can watch my videos on the lectures on the Unacademy platform. Okay.
Also, student, we have one announcement for you. There is a batch on 26th May, which is starting for EMT. You can enroll for that, and also you'll find the more information in the description. You can
you'll find the link for it in the description.
And you can enroll for that. Thank you for our side. Thank you.
Yeah. Thank you everyone for watching.
Thank you.
To life and freedom.